Okay, welcome back. Hopefully this slicing videos up into 10 to 15-minute bites is okay. Um, didn't want you to be sitting there for an hour dozing off. You probably are anyway. So we left off here talking about the evolution of the web. Now let's talk about how we can actually do this. So obviously there are a plethora of ways for building a web service. Okay, pick any way that you want. There have been two that have been kind of become more common to use, and one of them has really taken over. The first one is W3C Web Services, or SOAP, Simple Object Access Protocol. I think I've got the definition a few slides down. But basically, for the longest time, SOAP was the way that services would interact. It's really not that bad to spin up, but there's a lot more overhead, which is why, again, I'm not going to do a demo for it. Point you to some more resources if you want to see that. But basically, you are packaging up a XML request in kind of an envelope style fashion, which is one of the ways that they talk about SOAP. You're also packaging up packet information, message information. It's not just the data. The other way, which is more common these days, is using a RESTful service. Now, REST is something which you should already be intimately familiar with, whether you understand or not, or whether you realize it or not, I guess. This is what we are doing in Flask and Rails. We are doing RESTful routing. Now, effectively, what's going on is that we are just having a nice, easy to read URL for however we are routing through our site. Now, one example that's separate from web services, let's say you want to get into IoT. So you want to have a bunch of little networked microcomputers like Raspberry Pis, Arduinos, that kind of thing. And let's say that I wanted to get some data from one of them. Well, if I wanted to package this up with SOAP, I would need to build a SOAP request or a response, send a message to the device. It will build up this big XML packet and send it back, and I'd have to parse out this XML tree. Or I could just go to my IoT device and I will say, let's say its IP address is arduino.home. So I go to http arduino.home/get-temperature/sensor1. So basically, I've got a URL string that I'm building up, and I'm asking you to imagine it. All right, well, the Arduino is going to parse out that get temperature. Okay, I need to route them here, and then, sorry, getting pop-ups on my screen. Then device one or sensor one, it's basically going to then route, let's grab this sensor data specifically. And again, this is a bit of a mental thought exercise, but I'm just using very easy to read slugs for getting data. And the idea is that it's kind of built around the notion of the various HTTP verbs, which you all should hopefully remember from the first bit of the semester. So to kind of give you an idea of what we've got going on here, we're not going to get into each and every one of these boxes. I mainly wanted to give you a nice visual for how REST and SOAP work together, and we're going to come back to the differences over and over again. REST is basically at the HTTP verb layer. So when I call a GET in HTTP, I'm asking for some resource, right? That's basically the same thing in REST. So if I am going to a particular URL and the intent of that URL is to get some information, I'm going to call HTTP GET. Depending on your application, if I go to Arduino/edit/sensor1, well, hopefully that application is going to parse that out as I need to call the HTTP update verb. And again, we did this kind of natively in Rails. It was abstracted from us because it auto-generated all of those verbs for us, but that's the idea here, right? We are using these HTTP verbs. SOAP, on the other hand, is at a bit of a lower layer. So basically, this entire thing is responsible for building up the packets, and then we're just sending data over HTTP later on. And just got a little table here for you as well to kind of show you some of the differences. These I grabbed off of Google, and this is just protocol behind my face here. There's nothing else under that. But basically the idea is SOAP is XML, REST is architecture. SOAP uses WSDL, which we'll talk about very soon. REST uses XML or JSON. SOAP needs an RPC method. REST is just a URL, so on and so forth, basically. Other thing too, REST is very, 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 very easy to use with JavaScript or other scripting languages. SOAP, you need some libraries and you need to install some things to make it work. I'll let you kind of go through the rest of these as well. But to kind of generalize a bit here, if we are looking at building a web service, okay, we're going to consider from a higher perspective that SOAP and REST are probably at the same tier, the same presentation layer. Basically, we are requesting information, we are requesting to update information in some way. Whether it's SOAP or REST, the client doesn't care. All right, we are going to have some kind of a presentation layer, which is like your front end. The application will then get whatever your request is, and if it's SOAP, it's going to go to the SOAP bits. If it's REST, it's going to go to the REST bits. But the idea here is that we are building some kind of a service that is going to need this underpinning technology, and that's the entire purpose of the SOAP versus REST call. Another point to make here too, it doesn't just have to be you, the human, requesting this data. It could also be other programs. So if we go back to my home IoT environment example where I've got Arduinos and Pis everywhere, I don't think I have any here. I've got my little Lego Arduino boy here. So Arduino, Android. Let's say I've got a sensor in this, and maybe he is, other than his head spinning and me slowly losing my mind, he's monitoring the temperature, okay? And he detects that the temperature has dipped below an acceptable threshold for this room that I'm in. So maybe we need to kick on the heat or kick on the air conditioner. Well, if I've got an application here, my little Arduino could talk to the HVAC controller, it could turn on the air conditioner, it could turn on the heater, and it would communicate exactly the same as a human would communicate with the setup, right? It's just going to call a RESTful call, or it's going to make a SOAP call. The idea here is that if we are making interoperable services, programs can talk to programs, humans can talk to programs, and we still make things work. And this leads us into the idea of a service-oriented architecture. So this notion is that when you are building a distributed system, you want every bit to be service-oriented. And what that means is that if I'm building up pieces of this application, we are treating every one of these pieces as a service of some kind. Now, this is something that you should probably decide upon before you go into a build. You don't necessarily want to scrap everything and then, have to rebuild it as service-oriented. You want this in your head before you even get started. Now, depending on your setup, you might have big pieces are services, you might have little pieces are services, but the idea is that I'm going to build this module of some kind, right? So let's use our little puppet, Lego puppet here. All right, this is a temperature sensor. Pretend it's got a microcontroller inside and a temperature sensor on its antenna. I could expose this as a service by simply making it a RESTful server. So whenever I go to this thing's address, and if it's networked, it will have an IP address, and I call get temperature, this thing will return the temperature to me. Contrast that where if I had, this piece was simply a function in a bigger application, I would call that function and it would get the temperature back. But here, I'm exposing it as an internet resource. I'm making a RESTful call instead of a function call, effectively decoupling things, right? Let's say that poor Mr. Android goes down. That's really sad. It's fried because I plugged it into the wrong power source. Okay, well, I've got another toy here, right? Maybe this is a new model. It's going to talk as in the exact same fashion as my little Android did. It's going to report the same metrics via REST, and it's still accessible. All I would have to do is tweak the IP address because now I've got a new device in the system. The idea is with loosely coupling things, we are going to not make them be tightly intertwined with other classes. So this is a software engineering term, so those of you that have had me for software engineering before should remember this. But if you didn't, basically you want it to be, you don't want function calls, variables, all of this to be very tightly intertwined with your main program. You want it to just be this kind of black box that you call and you get some output back. All right. So this kind of setup here, now this is again just a generic Google image that I pulled. Here we have a big monolithic application. All right, so we have some service scheduling, order processing, account management, a bunch of databases down here. And this is all one big application. And these might be separate programs or separate services, but still one big thing. All right. Now, if we were to break this up into a service-oriented architecture, yes, we would still have these kind of big three pieces here, but we would have a set of services that we could kind of plug and play, right? Let's say that I've got a create invoice service, and it's probably in service scheduling. No, it'd be in this one, I guess. It's based on the colors. All right, so I want to create an invoice. Well, that's great, but maybe our salespeople promised something else and we need to update our invoice fields. Well, I just create a new invoice service, replace it, and in theory, it just kind of slots right in. Basically, think of these services as completely replaceable. As long as you're talking on the same protocol, it should be fine. All right, so to kind of round out service-oriented, there's a couple of different ways that we can structure them. If you want them to be real-time or deferrable, both of those are fine. Basically, it's just something you need to consider when you're setting the system up. If it's real-time, that means you need an immediate response. So something where it's very critical to get data quickly, like a stock market, banking application, healthcare data. If you're building an IoT system in an automobile, maybe you need very quickly timed responses. But the idea here is that as we kind of divvy up our services into these distributed setups, latency can start to become a concern. So that's one thing that you have to deal with when you build up these situations, right? Ideally, it's going to be as fast as possible, but depending on your network setup, it might be deferred. So I guess the idea is not necessarily this is something to get hung up on, it's just something to be aware of early on. So just some key terms for you before I close off this video. Some characteristics of service-oriented systems. Everything should be pretty much treated as a black box. So if I have some class or some module or some program, it is a black box. And what that means in terms of software engineering or development in general, I have this piece of software, okay? I have no idea what's inside of it. If we were to use a sorting algorithm example, right? I have a list that's going into this black box. I don't care what the sorting algorithm is. I just want that list sorted when it comes out. Basically, data goes in, gets transformed, comes out transformed. I could replace bubble sort with quick sort, and I would still get a sorted list, albeit a bit faster, right? So the idea with the service-oriented architecture is the same thing. I have a piece of the puzzle that I can put in. As long as it talks on the correct API, it should be fine, right? So we also have a verifiable identity and a well-defined set of interfaces. That means that I can't just put any service in. I need to make sure that it's the service that I need, right? So I'm not just injecting a Trojan or something bad into my system and it's just going to work. But it needs to be addressable. I need to call it. It needs to be known. And it also needs to provide an interface. And that interface is how we talk. That's the input and output expectation of our black box. Ideally, they're versioned as well. So maybe my user authentication module is at version 1.1, and I get a new software update, it's at version 1.1.1. Hopefully pretty much everything is versioned these days. It should be accessible. So if it's a service, it needs to talk on the network in some fashion, whether that's via XML or REST or a socket, as long as it's addressable, that's what we want. It needs to be invoked and invocable, and that just means that we have the ability to call it and access it and work with it, and that if something goes wrong, it can handle that issue, the error handling. So to just kind of talk about that, let's say that we want to create an invoice in our service-oriented architecture, okay? And the user makes a mistake, they put in the wrong name, and this throws the entire process off, okay, because they're not a verified user anymore. Well, maybe this service has a error recovering mechanism for handling that. Please enter your username again. Are you sure that you want to go through with this? Or if they added something in that breaks the system, we have like a try catch block in there that's going to hopefully handle something. But the idea is that every piece of the puzzle has its own error handling mechanism, and a failure in one doesn't impact everybody else. Okay, that's enough for this video. I will see you in the next one.